All right, everyone, welcome back. Today is day 2 of understanding equivalent fractions. Let's jump right in. All right, so yesterday we worked on using multiplication to find equivalent fractions. Equivalent means equal. So here's an example right here. We have 2/4. I multiplied both sides by 2, and we came up with 4/8. We're going to do 3 now together. The first one we'll do is 3/5. I'm going to multiply each one by 3. So we have 3 times 3 over 5 times 3. 3 times 3 is 9, and 5 times 3 is 15. So that means that 3/5, 3 over 5, is equal to 9/15. Let's do another one. 6 over 7. I'm going to multiply each one by 4 this time. So we have 6 times 4 over 7 times 4. 6 times 4 is 24, and 7 times 4 is 28. So that means that 6 over 7 is equal to 24 over 28. The last one we're going to do, I want to see if you catch something. Well, I'll ask you at the end. I'm going to multiply 1/2. I'm going to multiply each side by 2. So we have 1 times 2, and we have 2 times 2. 1 times 2 is 2. 2 times 2 is 4. Did you catch it? 2/4 and 2/4. So that shows us that you can make both the numerator and the denominator bigger, like we did in our first 3 examples, or we could actually make the numerator and denominator smaller, such as going from 2/4 to 1/2. And that's what we're going to learn today. Today we're going to learn about division and how to use division to make equivalent fractions. All right, so today what we're going to do is we're going to take a fraction and we're going to find an equivalent fraction that's smaller in both the numerator and the denominator. The fractions are actually equal. They're equivalent. It's just the numerator and the denominator which are going to get smaller. So let's look at our first example. Our first example shows 2, 1, 2 out of 4. 1, 2, 3, 4. How could we make this fraction equal, the same as it did before, have the same amount of area colored in, but change the numbers? What if I did this? I didn't change how much of my square here was colored in. All I did was change how many boxes make a total. Instead of 2/4, now I have 1/2. And so we know that 1/2 is equal to 2/4. But how would I have done that without the picture? How can I do that using our math skills, using division? Well, if we have 2/4, like we did in our original picture, and I'm cutting it in half. Right now it's 4, I'm making it 2. I'm cutting it in half. That's the same thing as dividing by 2. So this time, instead of multiplying, I'm going to do 2 divided by 2 and 4 divided by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. We get 1/2, 1/2. So you can use both division and multiplication to find equivalent fractions. Let's try another one that's a little bit bigger, but not necessarily any harder. So the next problem we're going to look at is 10/12. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 10 colored in. How could we use division to make this fraction equivalent, but have both the numerator and the denominator be smaller? Well, like we did here, let's try dividing by 2. So everywhere that I have 2, I'm going to make 1. So I take away this, I take away that, I take away that, take away this, this, and this. So again, I didn't change how much of our rectangle was colored in. That's the same. All I did was change how many boxes were in the total. Now, instead of having 12 total boxes, there are 6. 2 times 3. So in this problem, we have converted 10 over 12 into 1, 2, 3, 4, 5, 5 over 6. These are equivalent. Our picture never changed in size, and the amount shaded in never changed. All that changed was our total units. But how would we do this the mathematical way? How would we do this using division? Well, like before, we have our original 10 over 12. And when I cut it in half, when I got rid of half the lines, that's the same thing as dividing by 2. So we're going to divide by 2. 10 divided by 2 and 12 divided by 2. 10 divided by 2 is 5. Getting a little ahead of myself. And 12 divided by 2 is 6. 5/6. So either way we do it, we're going to come up with the same answer. Whether we change our drawing or we use division, we're going to get the same thing. If it helps you to use a picture, that's a great way to do it right now. But eventually, we're going to get to the point where we can use multiplication and division as the only way of finding equivalent fractions. Now we're going to move on to our book where we do some work. Now we're going to move on to our problem set. So, the first thing you're always going to do is put your name in. And remember, you need both a first and a last name. Then you move over to the actual questions. The instructions say, express the missing number to make equivalent fractions. So whatever we're missing, that's going to be our missing numbers. Express just means show, and we need to make equivalent fractions. So we need to make sure that they are equal. So for our first one, we have 6/10. 1, 2, 3, 4, 5, 6 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we need to make an equivalent fraction with our denominator at 5. Well, looking at my picture, how could I turn this 10 into a 5? I could get rid of the middle line. So now we have 1, 2, 3, 4, 5. And 3 are shaded in. 1, 2, 3. So 6 over 10 is equal to 3 over 5. Now this question just asked us to use the area model, so to do what we did here. But what if we had used division? Could we have solved it that way? Well, I know that 10 divided by 2 is equal to 5. So if 10 divided by 2 is equal to 5, then I should also be able to divide 6 by 2, and that gets 3. So either way, it would have worked. If you had used just the area model, which is what the instructions said to do, or if you want to try and use division, either way, 6 over 10 is equal to 3 over 5. So now that we're done doing the problem together, you're going to finish your problem sets on your own. For numbers 3 and 4, the instructions are use the area model to fill in the missing number. So you're going to use your picture to try and find out with an equivalent fraction for 6/8, and then you're going to use your picture to find an equivalent fraction for 4/6. For question number 5 and question number 6, the instructions say use division and draw an area model to find an equivalent fraction. So even if you're handing this in only online and can't draw a picture, it's still a good idea to do that, maybe on a scrap piece of paper or on something extra that you're using, so that you really learn how to do it that way. I'm not going to draw the picture for you, but if you draw something like that, you'll be able to get started. You just need to create 10 spots. And then on the last question, number 6, same thing. You're going to draw your own area model, and you're going to use that to find an equivalent fraction for 6/9. And that will be the end of your problem set. All right, that ends our lesson. You're going to go now and finish your independent work, and I hope you have a great rest of your day. Goodbye.